Moving into Unit 1.4, algebraic expressions, using substitution property, and how we evaluate using substitution property. Alright, so an algebraic expression is a mathematical, why do I do that? A mathematical phrase made up of numbers and variables. Oh, variables, here we go. Alright, the difference between an algebraic expression and an equation is the equal sign. The algebraic expression has numbers and variables, but no equal sign. I know, be careful. Right, substitution property says that if A equals B, remember this is one of our properties we talked about, right? We called it symmetrical property. It's the same thing. If A equals B, then A can be replaced with B, and vice versa, right? Then A may be replaced or substituted for B in any expression. Right? Think about it like this. You probably heard the term before. Teachers told you if you know the value, plug it in. Substitution property is what it's called. Right? And the idea is that if you know the value of the variable, then you can replace the variable with its actual value. Right? With its actual number. Right? To evaluate an expression with variable replacements, substitute the variables with their given values. Each time you substitute a variable with a number, put parentheses around the number so that you know what you substituted. Put parentheses around the number. Follow the order of operations to evaluate. Right? This is why you needed to know order of operations, because we're going to start playing with variables. We're going to substitute the variables for their actual values, and then you need to solve using order of operations. With me so far? Alright, let's work a couple of examples. Everybody good? I feel like you're right there watching me. I'm just going to keep asking you, do you need help? You'll probably get sick of my voice before it's over. Alright, directions. I think I want to make that bigger. I want you to be able to see what we're doing. Alright, evaluate each expression using the variable replacements. There's a lot going on in those directions. Evaluate, meaning solve. Each expression, meaning it's an expression, it doesn't have an equal sign, using the variable replacements, using substitution property, right? So, AB squared plus C, if A is 2, B is 4, C is 7. Right? All we have to do is replace, substitute the variable for the value. And remember, every time you replace a variable, put it in parentheses. I'll show you why. Right? If A is 2, it's going to be 2, and B is 4 squared, don't forget the squared, plus C, which is 7, right? The reason you need to make sure to put it in parentheses, because if you hadn't, you would have put 2, 4 squared plus 7. 24 squared plus 7 is not the correct problem. But because we put it in parentheses, we know that it's 2 times 4 squared. Right? Thus, the parentheses are important. If you come along and you realize they're not necessary, then you can drop them in the next step. It's not necessary for the 7, but you didn't know that until you wrote it down, right? Order of operations, nothing we can do inside the parentheses. There is an exponent, 4 squared, so it's going to be 2 times 16, because 4 squared is 16, plus 7. Now you see how I left it off this time? I didn't take the parentheses with me. I didn't need them for this one, but I did need them for this one, because we still need to multiply. Right? 2 times 16 is 32, plus 7. Now all the parentheses are gone. 32 and 7 is 39. Bam, just like that, we use substitution property to solve an algebraic expression. All right, again, don't forget parentheses. If x is -2, we can replace the x with -2. I'm going to show you another reason we use parentheses. We're replacing that x with -2 squared minus 4 -2. Right? Sometimes when it comes to the negative numbers, if you don't use the parentheses, when you square it, you're going to end up with the wrong answer. So just be careful, is all I'm saying. Alright? Nothing we can do inside the parentheses. We do have an exponent, so it's going to be 3. -2 squared is -2 times -2, which is 4, minus 4 times -2. We have 2 negatives. 4 times 2, -4 times -2. So it's going to become positive. Right? 4 times 2 is 8. Three times 4 is 12, plus 8. 12 and 8 is 20. Make sure you box or circle your final answer. This is how I know what your final answer is. Go back and double check and make sure you have the right sign. If your answer is positive, you can have a positive sign or no sign. But if your answer is negative, it has to have a negative where it's wrong. Double check your signs. The signs are the enemy. The negative sign will kill you every time. Double check your signs. Right? Questions? Questions? Alright, let's roll up. Let's see if we've got it figured out. A squared times b minus b squared. A is 3, b is -4. So a squared b minus b squared. Now you can see even more why you need the parentheses. That's a lot of negative signs. Let's work it through slowly. Nothing to do inside the parentheses. We do have an exponent here. 3 squared is 9 times -4 minus -4 squared is 16. 9 times -4 is -36 minus 16. -36 minus 16 is negative, because they're both negative. I went back 36 and I went back 16 more, so I went back 52, I think. 36 to 16 is 52, so it's -52. Now you know why I stressed this so much. It would suck to get all this right and mess it up right here. Alright? A squared times b minus b squared if a is 4 and b is -7. Alright, so a squared b minus b squared. I'm just substituting the value in place of the variable. Exponents first, because there's nothing to do inside the parentheses. So 4 squared is 16 times -7 minus -7 squared is 49. 16 times negative 7, so just do 16 times 7, 42, 7, 8, 9, 10, 11. And because there's only one negative sign, it's going to be negative 112 minus 49. Again, they're both negative, so add the numbers. 49, 51, 61, negative 161. Correct. Woo! Negative y squared minus 3xy. Woo, let's look at that one. I'm excited. I don't know why I love this stuff, but I do. Alright, negative y squared. So x is negative 4, y is 2. So negative 2 squared minus 3xy. Now ask yourself why I kept the negative outside of the parentheses. I kept it outside of the parentheses. That changes things. If it was inside the parentheses, negative 2 squared would be 4. But because it's outside the parentheses, 2 squared is 4, and then we bring over the negative. It changes the answer. Now, why would I keep it outside the parentheses? Invisible math. That's why. So if you have negative y squared, before every variable, if there is not a number, there is an invisible 1. So because y is 2, this negative y squared is actually negative 1 times 2 squared. So then you get negative 1 times 4, and that's negative 4. So if there is not a coefficient, the number before the variable is called a coefficient because it works together. Coefficients. If there is not a coefficient before a variable, there is an invisible 1. Whether it's negative or positive, it doesn't matter. If you have an x by itself, there's an invisible 1. If you have a negative x by itself, there's an invisible 1. Be careful because that's going to change your answer quite drastically. I'm just telling you. Alright, sorry, I got sidetracked. But you need to know information, right? You should probably rewind and watch that part again, and maybe a third time. Because invisible math. Alright, so 2 times 2 to the second power is 4, so negative 4. And then no other exponents. Right? The next thing is multiplication. Left to right, negative 3 times negative 4 is positive 12 times a positive 2. I just brought it down. Still with the multiplication, negative 4 plus 24. Different signs, I find the difference. The difference between the two is 20. The 24 has the greater absolute value, so I take that sign. Positive 20. They want you to do it again just to make sure you got it. Right? Negative y squared. Y is negative 12. So negative 12 squared minus 3. This is my coefficient. X. Oh, here we go. Y fractions. Y. Oh, they did that stuff on purpose. Don't panic. One step at a time. I showed you how to deal with multiplication and fractions. Right? We'll do it all together, one step at a time. Negative 12 squared is 12 times 12, which is 144. And then we bring down the negative sign. So negative 144 minus, it's going to be plus, right? Negative times a negative is a positive. Let's look at that 3. 3 times 5 over 6. Remember what I said. if you're going to multiply fractions, they have to both be fractions. 15 over 6, which simplifies, both can be divided by 3. This is how you simplify. 15 divided by 3 is 5. 6 divided by 3 is 2. So instead of putting all of this, we're just going to put 5 second times negative 12. And then we're going to do it all again because we have to multiply a fraction by a fraction. Alright, so 5 over 2 times negative 12. Put it over 1 so we can multiply two fractions. Alright, 5 times negative 12 is negative 60. 2 times 1. Half of negative 60 is negative 30. Remember, dividing by 2 just means half. Half. So we have negative 144 minus 30, which would be a negative 174. So they added fractions just to hurt your brain, but don't let them hurt your brain. Multiplying by fractions is super easy. You multiply across to get this, and then you multiply across to get this. If this isn't there, put it there. Make it visible. No invisible math. Make it all visible. And all I did to simplify